Have you ever watched a news report about a hurricane? I'm talking category 3, 4, winds over 125 miles per hour, and notice that some houses just disappear. Not damaged, not flooded, disappeared, walls shattered, roofs toppled in the air like playing cards. And then, right in that same report, you see a concrete house, still standing. Broken windows, yes. The yard destroyed, but the walls solid, the roof still on, and you probably had a thought you didn't say out loud. Why do we keep building like this? That's exactly what we're going to answer today, and I promise you, the real answer is far more fascinating than you think. By the end of this video, you're going to look at every house you drive past in a completely different way. You're going to understand something about American culture that most Americans have never consciously considered. Stick around. Things get genuinely interesting around the 5-minute mark. First, I need to clear up a mental image you probably have right now. When I say Latin American construction, your brain might be picturing shacks, unfinished buildings, steel rebar sticking out of roofs. Forget that image completely. I'm talking about the standard middle-class residential construction system used in Mexico, Colombia, Peru, Brazil, and Argentina, countries with a combined population of over 400 million people. I'm talking about houses that routinely outlive their owners, houses built by grandparents and still lived in by grandchildren, concrete block houses, reinforced with steel rebar, cast-in-place concrete columns, the whole shebang. Here's a number that will change your perspective. The average wood frame house in the United States is designed and built to last 30 to 50 years. The average concrete house in Latin America lasts 80 to 100 years, sometimes longer. Same price range, radically different lifespans. Now you want to know why, so let's get down to business. Let me show you what Latin American residential construction is really like, because most Americans have genuinely never seen it. It starts with the foundation, not a shallow concrete slab like most American houses sit on, a real deep foundation, with footings that reach down to firm ground. In earthquake-prone cities like Mexico City or Bogota, these foundations are engineered to flex. They aren't just poured concrete, they're calculated. Then come the columns, vertical steel rebar cages placed at every corner and every wall junction, filled with poured concrete. These columns are the skeleton of the house. They aren't optional and they aren't decorative. They're literally holding everything up. Then come the walls, concrete blocks, or in some regions, solid brick partitions laid course by course between the columns. No gaps, no cavities, solid mass from side to side. The roof is a poured concrete slab, reinforced with a rebar grid about 10 to 12 centimeters thick. Now, here's what that process means in practice. It's slow. A house like this takes months to build, sometimes more than a year for a family doing it in stages. Each pour needs to set. Each course of blocks needs to settle. You can't rush the concrete. It's heavy. We're talking about a 2-story house that can weigh 400, 500 tons. The foundation has to support that. The ground has to support that. And it's expensive to modify. Want to move a wall 10 years later? You're not just removing drywall and repositioning studs. You're using a jackhammer. So why do hundreds of millions of people choose this system? Because of what you get in return for all that work. You get a house that laughs in the face of a hurricane. Seriously, category 4 winds don't budge a concrete wall. They don't budge. You get a house that won't burn in a wildfire. Concrete doesn't smolder. You get a house that won't rot, that termites won't eat, that doesn't need refacing every 15 years. You get a house where the interior temperature stays remarkably stable without a massive HVAC system running at full blast, because all that thermal mass absorbs heat during the day and slowly releases it at night. And you get something most Americans don't even have a frame of reference for. You get a house you can leave to your children, not in the financial sense, not as an investment asset, in the physical sense. The building itself, the walls, the roof, the floors, still there, still solid. 2 generations later, in Latin America, when someone builds a house, they're not thinking about the next buyer, they're thinking about their grandchildren. That's a completely different psychology than the one driving American residential construction. And understanding why American construction evolves so differently, that's where things get really interesting. To understand American wood frame construction, you have to go back to the 1830s and 1840s. The United States was expanding westward at a rate the world had never never seen. Towns needed to appear, not in years, but in months. There was no time, no skilled labor, and frankly, no need for permanence. A town could rise and fall in 5 years. You needed shelter, fast. Lumber was everywhere. The forests of the eastern United States and later the Pacific Northwest were virtually limitless, or so it seemed, and a revolutionary construction technique called balloon framing was spreading rapidly. Thin, standardized pieces of lumber, machine-cut nails. Anyone could learn it in days. A house could go up in a week. Compare that to masonry construction, which requires skilled masons, heavy materials, and weeks of curing. In a country growing as rapidly as the United States, masonry felt like building a cathedral when you needed a tent. Then lumber won, and once lumber won, everything else in American society was organized around it. The lumber industry scaled up. Standardized lumber sizes became universal. Building codes were written around lumber. Banks learned to appraise wood frame homes. Insurance companies learned to quote them. Contractors were trained exclusively in wood. Architects designed for wood. By the time anyone seriously questioned whether lumber was the right choice, the entire infrastructure of American housing was so deeply intertwined with it that change was almost unthinkable. Here's the uncomfortable question no one wants to ask. Those original reasons, unlimited forests, rapid expansion, impermanent settlements, do those reasons still apply in 2025? Because right now, roughly 500,000 new wood frame homes are being built in the United States every year. Many of them in Florida, many of them in Texas, many of them directly in the path of hurricanes, wildfires, and tornadoes that are intensifying every decade. And every time one of those disasters strikes, every time we see an entire wood frame subdivision wiped off the map, we rebuild in wood. Now, before this turns into a TED Talk on climate change, I want to get into the actual engineering, because this is where the Latin American system has some genuinely amazing advantages and some serious disadvantages that the concrete crowd generally doesn't want to admit. Let's be fair to both systems, because both have real and legitimate advantages. This isn't a good concrete, bad wood video where wood framing genuinely wins speed and cost of construction. A wood frame house in the United States typically takes 3 to 6 months to build. Concrete masonry, 12 to 18 months minimum in most Latin American markets. In a country with high labor costs, time is money in a very direct way. Flexibility. Want to renovate? Add a room? Change the electrical wiring? In a wood frame house, you're removing drywall and moving studs. Evening job. In a concrete house, you're calling a structural engineer and renting a jackhammer. Weekday job. Thermal performance in cold climates. Well-insulated wood framing is truly excellent in places like Minnesota or Michigan. The cavity walls retain insulation in a way that solid concrete walls simply can't. Seismic performance. And this one surprises people. A well-built wood frame is actually more flexible in an earthquake than a rigid concrete block wall. Remember, flexible bends, rigid breaks. That's why Japan and Chile, two of the most seismically active countries on the planet, use lightweight construction extensively. Where concrete masonry truly wins, resistance to hurricanes and high winds. No competition. This doesn't even come close. Fire resistance. Concrete doesn't burn. The 2025 Los Angeles wildfires destroyed thousands of wood frame homes. Concrete homes in those same neighborhoods still standing. Longevity and maintenance costs. The initial cost of concrete construction is higher, but over 50 years, the cost of maintaining a concrete home is dramatically lower. No cladding, no rot proofing, no termite treatments. Sound insulation. A concrete wall is essentially a sound barrier. A wood frame wall with drywall is not. And the big one, the one insurers are starting to take into account, the cost of replacement after a disaster. The average insurance payout for a wood frame home destroyed by a hurricane in Florida is over $200,000. A concrete home in the same storm, broken windows, maybe $15,000. Multiply that by thousands of homes. Multiply that by decades of increasingly intense hurricane seasons. The numbers are starting to change. Here comes the most interesting part of this whole video. Everything I just described, all the durability advantages of concrete construction you can have in the United States right now with a product made in America that already meets American building codes. It's called ICF. Insulated concrete forms. Here's how it works. Instead of pouring concrete into traditional wood or metal formwork that's later removed, ICF uses permanent foam blocks, like giant Lego bricks that you stack to form your walls, then fill with rebar and poured concrete. The foam stays permanently in place, acting as insulation on both sides of the concrete wall. The result? You get the strength of concrete, hurricane certified, fire resistant, built to last a century. A combined with insulation value values that actually surpass standard wood frame construction. The finished house looks exactly like any other house on the street. ICF homes cost approximately 3 to 8% more to build initially, but they cost dramatically less in insurance, heating, and cooling, and essentially nothing in structural maintenance. ICF specialist builders say the same thing. Once a client builds an ICF home, they never go back. So let's go back to where we started. Why don't we build like Latin Americans? Because the United States built its entire construction industry during a period of unlimited resources, unlimited land, and a fundamental cultural assumption that a house isn't forever. It's a chapter. You build it, live in it, sell it, someone else remodels it, and eventually it's demolished and replaced. In Latin America, a house isn't a chapter. A house is a statement. It says, I was here, my family was here, and this wall is proof. Neither of those philosophies is wrong. They're simply different answers to the question, what is a house for? But this is true. The conditions that made wood frame construction logical, abundant forests, a rapidly expanding frontier, everything fast and cheap, those conditions no longer exist. The forests aren't unlimited, the frontier is closed, and hurricanes aren't decreasing. Latin American building traditions discovered something long ago that we are only now rediscovering through billions of dollars in insurance losses and entire neighborhoods reduced to ash. Building slowly and building solidly is not outdated. It's simply thinking about the future. Maybe it's time we started building as if we plan to stay. That's the big picture. American wood frame construction, fast, flexible, optimized for a country that was always on the move. Latin American concrete construction, slow, permanent, optimized for a family that plans to stay. Two different answers to the same question, and the world is changing in ways that make us rethink which answer fits better. Now I want to hear from you. Would you pay more upfront for a concrete or ICF home, knowing it could outlast your mortgage, your renovation plans, and maybe even you? Leave it in the comments. I read them all. If this video made you think differently about something you've seen your whole life behind the wheel, that's all I wanted. Like it if it did, and I'll see you in the next video.